Welcome back to module 5 of the unit analysis of time series, and we will be talking about the method of least squares in this module. Recall that we are discussing how to measure a trend in a time series, and in this regard we have already discussed about three methods, that is the graphic method, the moving averages method, and the semi-averages method. This method of least squares is also a method that is used in fitting a line to the time series, except that unlike semi-averages method, where we divide the data into two equal halves and then use those averages for both the halves as the points to fit a line, the method of least squares, okay, is a far better method, okay, and this is the one that is usually used or widely used in fitting a line to the given data points. Okay. Now the principle that it works on is to minimize the deviations of each of the point from the line that we want to fit. Okay, so it minimizes the sum of the squares of the residuals. Okay, so if you look at this picture here, the blue points here are the actual data points, and we are fitting a line here. Okay, we can fit infinitely many lines to these data points, but we are looking at that point, okay, which minimizes the deviations of all these points from that line. Okay, so the method of least squares works on this principle, and that is why this is one of the best method that can be used in fitting a line to a time series. So the line that we want to fit, okay, we already know the equation of the line can be written in the form of y equal to a plus bt. Now here the time series is given in terms of the time t and the variable y that we are talking about, that depends on t. So the relation between the time series and the time series y and the time t is expressed as, this is the equation, the usual equation of the line that we know. Okay, so to find out this equation, what we need to find out are the two parameters a and b. If I know what is a and b, I can very well define the line that we are talking about. So the values of this a and b are estimated using two equations, which are given by summation y equal to n times a plus b summation t, and summation ty is equal to a summation t plus b summation t square. Okay, these two equations are usually referred to as normal equations or least square equations. Okay, now for the sake of remembering, what you can do is, you can see that if I just take the summation throughout this equation here, the equation of the line that we wrote here, what we'll get is the first equation, and if you multiply this equation throughout by t. Okay, so what I'll get is t into y is equal to a times t plus b into t square. I have multiplied this throughout by t. Okay, and then I take a sort of a summation. So summation of this is equal to summation of a is a constant, so you can keep it out, plus b into summation of t square. So for the sake of remembering, you can remember these two equations in that form. So given a time series, the data which will be in terms of t and y, the equation of the line that we assume is y equal to a plus bt. All that I have to do is find the value of a and b, which can be found out by using these two equations. Let's say, for example, I have this data here. The data here shows the production of sugar in 1000 tons from 2009 to 2015. Okay, so the year t is equal to from 2009 to 2015, and the production y are these values: 77, 88, 94, 85, 91, 98 and 90. So I want to fit a line of by using the method of least square to this data. Okay, so what we do is, the equation that we are looking at is a plus bt, and to find out this a and b, we use the normal equations. Summation y is equal to n times a plus b summation t. Summation ty is equal to a summation t plus b summation t square. Okay, so what we need to find out this a and b, what we need is summation y. N is the number of data points, that is 1, 2, 3, 4, 5, 6, 7 here. What we need is summation t, that is the sum of all these t values. We need summation of ty, t into y. So basically I have to multiply t into y and then find sum over it. Summation t, that is the sum here, and summation t square. So for each of this t, I'll have to find out t square values and find the sum over it. Okay, so what we do is, of course this can be done, but because this t values are in terms of years, to avoid these big values, what we do is we transform this t in terms of another variable x by defining x as t minus, so it's sort of the assumed mean method that we are using here. So I'll define x as equal to t minus, now here 1 2 3 4 5 6 7, I have 7 t value, odd number of t values, so I have exactly one middle year. So what I do is I define x is equal to t minus the middle year here, 2012. By doing this, I will be able to reduce these values from which are big enough, which are difficult to calculate otherwise. Okay, so now here in this case the number of years is odd, so I could get exactly one middle year, so I can directly define x is equal to t minus 2012, that is the middle year. So once I do that, then this equation, instead of finding it in this original form, we will be finding the equation as y equal to a plus b x now. In place of t, we write it x. Okay, and this a and b will be found by the equation summation y is equal to n times a plus b summation x now, and summation xy is equal to a summation x plus b summation x square. So though originally the equation that we want to find out is this, what we do is for the computational purpose, the equations that we use are actually this. So this is the equation that we start with. We will be using these normal equations in finding the values of a and b, and once I get this equation, I can always substitute this x equal to t minus 2012 to get the original equation in terms of y and t. Okay, so let us proceed. So I have this data here. Okay, so this is t, this is y. So what I have to do is I have to first define x. So I'll define x is equal to t minus 2012, because 2012 is the middle year. Now why I'm selecting this 2012 as the year here is because it will simplify our further calculations. Okay, I could have selected any other year for that matter, but then choosing the middle year will simplify the further calculations, and that is why I choose this. So if I put t, so depending on the value of t, if I put t equal to 2009, so 2009 minus 2012 is minus 3. For 2010, so t is equal to 2010, in that case 2010 minus 2012 is minus 2. For 2011 it will be minus 1, 2011 minus 2012. For 2012 it will be 2012 minus 2012, that will be 0. For 2013 minus 2012 it will be 1. For 2014 minus 2012 will be 2, and 2015 minus 2012 will be 3. Now because I chose 2012 here, if you add this summation x, if you just add minus 3 plus 3 minus 2 plus 2 minus 1 plus 1, they'll all cancel each other and I'll get 0. Besides that, recall that the equation that we are looking at is a plus bx, okay, where summation y, for the values of a and b, the normal equations are summation y is equal to n times a plus b summation x, and summation xy is equal to a summation x plus b summation x square. So summation y I'll get from here. I have to just add all these values here. Then what I need is summation x, which I got here. I need summation xy and I need x square. So I make a column for x square and I make a column for xy. So xy here and x square here. So for x into y, I have to multiply this x value to this y values. Okay, so minus 3 into 77 is minus 231. Minus 2 into 88 is minus 176. Minus 1 into 94 is minus 94. 0 into 85 is 0. 1 into 91 is 91. 2 into 98 is 196. And 3 into 90 is 270. So if I add all this, I'll get summation xy. So if I add minus 231 minus 176 minus 94 plus 0 plus 91 plus 196 plus 270, this will come to 56. The same way I find out x square. So I have to take square of this x values. Minus 3 square is 9, minus 2 square is 4, minus 1 square is 1, 0 square is 0, 1 square 1, 2 square 4 and 3 square 9. Okay, so if I add all this, I'll get summation x square, that is equal to 28. Besides that, what I need is summation y. So if I add all this 77, 88 till 90, this sum comes to 623. Okay, so once I get these values, I go to these equations. So summation y is 623, that is equal to n is here the number of points 1, 2, 3, 4, 5, 6, 7. N is 7. A plus b into summation x. Summation x is 0. So this will be 0. So this equation will straight away give me A. A will be equal to 623 divided by 7. I cross multiply this 7. Okay. So that will give me 89. Now this is the reason why I chose this, I defined this x this way, because moment I got summation x is equal to 0, this b variable directly got vanished here because we multiplied with 0, and I directly got a equal to the value that I need. Now if I had chosen some other year here instead of 2012, this sum wouldn't have come 0 here. In that case I'll get this b would remain. In the only difficulty will be then I'll have to solve two simultaneous equations. So if I go to the next equation here, summation xy is 56, that is equal to a into summation x is 0 plus b into summation x square is 28. So this is 0 now. Here I'll get straight away the value of b, it is 56 divided by 28, that is equal to 2. So the equation that we are looking at is y is equal to a, that is 89, plus b, that is 2 into x. Now if I want to transform it into the original form, that is in t, I can always write it as 89 plus 2 into x is t minus 2012. So this is the equation of the line that we are looking at, equation of best fit. Now this equation can very well be used in estimating the values for forecasting. Suppose I want to predict what is the value for 2016, the future value. All that I have to do is find out the x value, or substitute this t is equal to 2016 here. So y will be equal to 89 plus 2 into, I am putting t equal to 2016. So 2016 minus 2012 is 4. That you can also directly write x value. X value for 2016 will be equal to 4, the next value here. So it will be 4. So it will be 89 plus 2 into 4, that is 8, that is equal to 97. So I've used these equations in estimating what will be the value for 2016, that is the production for 2016. So this is how we find out the equation of line by using the method of least squares. Let us go to the next example. Okay, so the only difference here in this example that I am considering here is the number of data points that I consider 1, 2, 3, 4, 5, 6, 7, 8. Even number of points. So I don't have exactly a middle here. Okay, in that case what we do is, the only difference is we take the arithmetic mean of the middle 2 years. Okay, so here these are the middle 2 years. Anyway, so we have originally the equation that we want to find out is y equal to a plus bt, and this a and b have those two can be found out by using these normal equations. Now for simplicity, what we do is, in this case we define x as, okay, it is defined as t minus, it is the arithmetic mean of the middle 2 years. Okay, so it is 2015 plus 2016 divided by 2 divided by, it is half into the interval. Okay, interval is basically the difference in the consecutive terms here, 2012 to 2013 to 14. Here the interval is of 1 year, okay, or 1 unit. So this interval refers to this. If it was like 2012, 2014, 2016, then interval would have been 2 and so on. If you take 2010, 2020, 2030 and so on, then the interval would be 10. Okay, so this interval refers to the difference between the consecutive t values here. Okay, so this is how we find out the value of x in case the number of terms is even. In this case, x will be equal to t minus 2015 plus 2016 upon 2. It is the midpoint of these 2 years. It is 2015.5. This divided by half into here interval is 1. Interval is 1. Okay, so this 2 I can cross multiply, take it on top. So this will give me x is equal to 2 gets multiplied to this t minus 2015.5. Okay, so this will be the only difference in this example here, where the number of years here is even. In case the number of years is odd, then I get directly a middle year in the previous example. In case it is even, this is exactly what we do. Take the middle 2 years. Okay, take the arithmetic mean of the middle 2 years, and then denominator is half into the interval. Interval is the difference between the consecutive t values. So if I go to this example here now, so we'll proceed the same way. So I'll define, so we have defined x here as 2 times t minus 2015.5. Okay, so accordingly, when you put each of this value here for 2000, when you put 2015 minus 2015.5 will be minus 0.5. Minus 0.5 into 2 will be equal to minus 1. So for 2015 it will be minus 1. For 2016 it will be plus 1. For 2014 it will be equal to minus 3. When you put t equal to 2014, this will be minus 1.5, and minus 1.5 into 2 will be minus 3. So accordingly this will be minus 5, this will be minus 7. So this will be for 2017 it will be 3, this will be 5, and this will be 7. Now because I define my x this way by doing this arithmetic mean, when I take summation x, this is going to be equal to 0, and that is the reason why we suggest defining x this way, because this will also simplify our future calculations. What we need is xy and x square in the equation, normal equations. So if I find xy, so you have to multiply these x values to this y values. So minus 7 into 550, minus 3850, minus 5 into 560 is minus 2800, then minus 3 into 555 is minus 1665, minus 1 into 585 is minus 585, 1 into 540, 3 into 525 is 1575, 5 into 545 is 2725, and 7 into 585 is 4095. So summation xy, if I find the sum of all this, this will come to 35. The same way, now then we need x square. So square values of all these x values. Minus 7 square is 49, minus 5 square 25, minus 3 square 9, minus 1 square 1 here, 3 square 9, 5 square 25, 7 square 49. So if I add these values, this comes to 168. So let us go to the equation. Y is equal to a plus bx is the equation of the line that we are looking at. With the normal equations, summation y is equal to n times a plus b summation x, and summation xy is equal to a summation x plus b summation x square. So using the first equation, summation y here is the sum of all the y values, that comes to 4445. So it is 4445 is equal to n here is 8, number of years is 8 into a plus b into summation x, which is equal to 0 because of the reason how we have defined this x. So this will give me a as equal to 4445 upon 8, and that will come to 555.63. I use the other equation, summation xy here is 35, that is equal to a into summation x, that is 0, plus b into summation x square is 168. So this will give me the value of b. It is 35 upon 168, and that is equal to 0.21. So I got a, I got b, so I can write the equation of the line. It is a, that is 555.63, plus b, that is 0.21 into x. In the original form, it will be 555.63 plus 0.21 into x. We have defined it as this. So it is 2 into t minus 2015.5. Okay, so this you can rewrite as 555.63 plus 2 into 0.21 is 0.42 into t minus 2015.5. So this is the equation that we are looking at. If you want, this equation then can be used even in estimating the values before and after, or any intermediate term or the value in the t values.